Let's do one more thing with our global data. So in this example, we only have two entries in our data. We have the alligator configuration and the monkey configuration. One thing I'm concerned about is for larger scale projects, it's entirely possible that we have dozens of these configurations. This makes it very tedious to make any sort of structural change when we have so many different definitions already implemented, especially when we're creating a new type of enemy and we want to add a new piece of data that is specific to that enemy. One of the problems is that all of our previous definitions would need to be updated. So the question here is, how can we set up this data so that it is easy to modify in the future and easy to modify for all existing data definitions without having to engage in a ton of tedious updates, going through each one at a time very slowly. And the best way that we can solve this is by defining defaults. So just as we've defined defaults for other local config structs in previous examples, we can define defaults for our global data. Let's quickly go over how to do that. So on the left side, we have our global enemy data. On the right side, we have an empty window. Let's fill this by creating a new script. We're going to call this IGlobalData. Now I'm using this capital letter I to borrow from the idea of interfaces seen in other programming languages. This isn't explicitly an interface, as it doesn't define a set of required methods, but it is inspired loosely by that idea because it defines a series of required data fields. So ultimately, you could name this whatever you wanted to. I'm just going to use this capital I as it's a pattern that I have adopted recently. Okay, I'm going to define this as a constructor. We want to be able to create instances of this class. Now I'm going to take a look at our enemy alligator. And the idea here is that we want to replace the implementation of this anonymous struct with the implementation of our new constructor. So to do that, I will simply say new IGlobalEnemyData. And I will wrap all of this inside of this new constructor. Now we're going to do some things that we've done in previous videos, which is use the combination of a config struct plus nullish operators to define our defaults. So you'll notice every single time we define default values, we follow the same set of steps. So that means our constructor needs to take in a config struct. And now I will start to define some default entries. So if we take a look at our data on the left, we notice that at this first level of nesting, we have several different fields. We have a UID, we have a name, description, combat, and sprite. So here, let's go ahead and start at the top and let's do our UID first. So UID is equal to config of UID. Otherwise, we will default this to undefined. Name is config of name. Otherwise, this is empty string. Description is config of description. Otherwise, we will default this to an ellipse. Combat will be config of combat. Otherwise, this will be an empty struct. Sprite will be config of sprite. Otherwise, this will be an empty struct. So for example, if I were to remove every piece of data here and just instantiate this with no data passed in, we would get all of our default values here. And if I only wanted to define a few entries without defining everything, I could do that by saying UID is enemy alligator and name is alligator. So now I've only defined two entries and the rest of our entries will be defaulted. Now I'm going to return this back to how we had it. And one thing you'll notice is that combat and sprite are also nested structs. This means that there may be default values that we want to implement at these levels of nesting. So we may want to have default combat struct values and default sprite struct values. So how would we do that? Well, I can create another struct definition, IGlobalEnemyData of combat, and IGlobalEnemyData of sprite. Here, I will say that combat, we have a life value that's going to get read from our config, an attack value, and a defense value. Now I need to implement this. So inside of our data on the left-hand side, we're going to do the same thing. We will say new IGlobalEnemyData of combat. We also need to make sure that we implement it up here in our original constructor, new IGlobalEnemyData combat. And lastly, we can go ahead and do that for our sprite. Idle is config of idle. Otherwise, it is a struct containing an index Now I will implement it. So here I have it implemented in the alligator and the monkey. And remember, the idea here is again to allow for any of these fields to be empty. So at any point during this data, I can completely rip out one of these definitions and still have functional data that is inserted into this data configuration. That was the first goal we wanted to accomplish, was allow for modular, optional, defaulted values. The other thing that we said we wanted to do was to allow for easy expansion. Let's say later on in the project, we decide to implement some movement, and the movement is only going to be specific to the monkey. So I want to add a new region here called movement. And I want to do things like move speed. Now, if I had 50 enemy here in this file, I would have to go through and manually add this movement section into every single piece of data that has already been defined. Because if we don't, when we go to read this data in the object's create event, we would crash. So by using this pseudo interface, what we're able to do is we're allowed to easily add new features in. Let's start by defining a new section called global enemy data movement, and movement is going to be config of movement. Otherwise it will be a struct containing speed of 100. So now I will implement it, and I will also implement it in our general data. So now I've defined some very specific data here to the monkey, and I don't have to go back and update any of the other data definitions. By creating this default constructor and injecting it in our IGlobalEnemy data, it will automatically be implemented into every instance of this IGlobalEnemy data. So we're able to make the addition in just one place by simply adding it here, defining that template here, and then overriding it in the specific implementation. So here, I'll add another field here. Let's add this. I'm going to say enabled by default is going to be false because we want this movement to be specific to just the monkey. So now I will say enabled is true. So then in our object's create event, when we go to read this data, we'll see that movement enabled is false for all cases. We'll handle that. But then in the case of the monkey, we'll see that movement enabled is true, and we can handle that appropriately then there too. All right, so that's it for this video. This is a weird edge case that I'm trying to cover, and this is really only a problem when you have projects that begin to scale up in size. For most of you, this won't ever be a technique that you will really need to implement, but it is a way to clearly define what the expected values are and to override them and implement them in custom ways unique to each enemy type in this example. All right, that's it for today. If you have any questions, leave them down below, and I'll see you later.